So the rest of section 10.1, this is what you're going to see in 10.1b, is going to be looking at a process that's called completing the square. So everything in 10.1a, it was already written in terms of something being squared. What you're going to be looking at here is not going to be in that format. You're going to have to get it to that format. And so what you want to do is get your polynomial or your equation to something that involves a perfect square. So let's just review for a minute what a perfect square trinomial would look like. The first example you have here is x squared plus 4x plus 4. If you were going to factor that, right, you would say, okay, I need two numbers that multiply to give me 4 and add to give me 4. Those would be positive 2 and positive 2. And so notice how this would become a perfect square. X plus 2 squared. All right, that's a perfect square trinomial. Similar thing for the second one here. If I were going to try to factor this one, I would need two numbers that multiply to give me positive 25 and add to give me negative 10. That would be negative 5 and negative 5, which again would give me a perfect square when factored. All right, and just to show you one more here, if I were going to factor this last one, I would need two numbers that multiply to give me 9 and add to give me 6. That would be positive 3 and positive 3. So again, I would end up with a perfect square. And when I have a perfect square, that's when I can use the square root property, which is what we're working towards here. So because we're going to be trying to create a perfect square, I want you to notice the relationship between the b term, the coefficient of the x, and the constant term, all right, the value on the end for these perfect square trinomials, right? For example, the first one we did, x squared plus 4x plus 4. What you're going to find is that the constant term, all right, this term right here on the end, is always going to equal 1/2 of the middle term squared, right? If I took 1/2 of the middle term, that would be 2 squared. 2 squared is 4, and notice that's my last term. And that'll happen every time you have a perfect square, right? So over here, if I took 1/2 of the middle term, that's negative 10 right here, and then I squared it, right? Negative 1, or 1/2 times negative 10 would be negative 5, and if I squared it, I get positive 25, and notice that's that last term. All right, and just to show it's going to be this way every time, right, for the third one that we looked at here, if I took 1/2 of the middle term and squared it, all right, that would be, not 1/2 of 3, sorry, 1/2 of the middle term, which is 6. That would be 3 squared, which is in turn going to give me that last constant term of 9. So what you want to notice here is that the last term, the constant term in any perfect square trinomial, is always going to be 1/2 of what we call the b term. That's the middle term, the coefficient of x, squared. And if we add that to something that is not a perfect square trinomial, then what we'll do is we'll create one so that when we factor, we can use the square root property. And that's our goal here. All right, so let's first start out with just making sure we understand what we need to add to get a perfect square. All right, so notice the instructions on these. We want to find what completes the square. And that will always be 1/2 of the middle term. Now the middle term here is 2. And don't forget to square it. So 1/2 of 2 is 1. 1 squared is 1. And so that's what I would need to add to create a perfect square. And notice it does create a perfect square. If I were going to factor this, I would need two numbers that multiply to give me positive 1, add to give me positive 2. That would be positive 1 and positive 1, or y plus 1 squared, right? That's what we're trying to do, create that perfect square. Now make sure when you're taking half of the b term, that middle term, that you do include the sign. So like here, the middle term is negative 8. So I would take 1/2 of negative 8, and I would square it. All right, that means I'm taking negative 4 squared, which is 16. So I would need to add 16 here to create the perfect square. And then notice when I factor this, it will be a perfect square. I would need two numbers that multiply to give me positive 16, add to give me negative 8. That would be negative 4 and negative 4. And again, there's my perfect square. Now, you may end up in some cases with something that doesn't divide nicely, right? If you have an odd middle term, and that's okay. It just means you're going to end up with a fraction on the end. So like, for example, here, my middle term is 5. So if I want to complete the square, if I want to create a perfect square, I would take 1/2 of that b term, just like I do for any other, and I would square it. So 1/2 of 5, this means I'm going to be taking 5 halves squared, square the top and square the bottom, and that would tell me I'm going to add 25 over 4 to complete the square. Now, sometimes when you end up with fractions, it's not quite as easy to see the factors in that perfect square. So what you can remember is that when you factor, the number that's used in your factor is always going to be this 1/2 of b. Whatever you squared, you can see that up here, right? So what I ended up squaring was 1, and that's what was included in my factor. All right, what I ended up squaring over here was negative 4, and that's what was included in my factor. So over here, if what I'm squaring is 5 halves, then I know this is going to factor into x plus 5 halves times x plus 5 halves. All right, let's look at one more with a fraction just to make sure that you're seeing that, because that will be a big help to you in factoring these if you can remember that. So over here, you want to note that technically the middle term here is negative 1. So when I come in here and I take 1/2 of the b term, all right, that's negative 1, and then I'm going to need to square it. So this means I'm going to be taking negative 1/2 squared, square the top, square the bottom. That means I need to add 1/4 to both sides. Now again, when you have a fraction, sometimes it's a little bit harder to see what the factors are going to be, but if you'll look right back here, right, whatever you got when you took 1/2 of the b term, that's what's going to be in your factors. This is negative 1/2, so I'm going to have x minus 1/2 and x minus 1/2 to create my two factors. All right, so again, this is called completing the square because all we're doing is we're adding a number that will create a perfect square trinomial when we factor. Now, when we do this to an equation, we end up with something that's in a format where we can solve using the square root property. All right, so now that you know a little bit about how you complete the square, what you want to do is use this information to solve an equation. All right, so we're going to look at some different types of examples. One really important thing to note is before you go through and complete the square, you want to make sure that you isolate your variables on one side by themselves. So notice here I've got y squared and I've got y on one side. I got negative 8, which doesn't have a variable on the other side. I always want to make sure that it's like that. Now, what I'm going to be doing when I complete the square is I'm going to be adding something to both sides. So I'm going to rewrite this as y squared plus 6y, and I'm going to put a little blank for where I complete the square. And then on the other side, I'm going to do the same thing. I've got a negative 8, and I'm going to add a little blank. Because remember, if you don't want to change an equation, whatever you add to one side, you have to add the exact same thing to the other side. Now, what I want to add here is just what we used above. I want to take 1/2 of that middle term and square. So in this case, I'm going to be taking 3 squared, or I'm going to be adding 9 to both sides. So I'm going to put that 9 here and here. You can't just add it to one side. That'll change your equation. You got to keep the balance. Now, what I end up with on the left-hand side is a perfect square trinomial, right? If I go to factor this, two numbers that would multiply to give me positive 9, add to give me positive 6. That's positive 3 and positive 3, which notice is that same 1/2 the b term. And then on the other side, I have negative 8 plus 9, so I'm going to be left with a positive 1 over here. So because I've created a perfect square now, I can write the left-hand side as y plus 3 squared is equal to 1. Now notice, this looks like the equations that we solved in 10.1a. You've got everything being squared on one side, and when you have that, you can solve by taking the square root of both sides, right? You just have to remember for the constant term here to include a plus or minus. Now again, when I take the square root of y plus 3 squared, all right, that's going to kind of undo the square, so I'm going to be left with just y plus 3 on the left-hand side. And then the square root of 1 is 1, but I want to make sure I don't forget that plus or minus. And then just like we did with the square root property, we'll continue. We want to get y by itself. So we'll subtract that 3 from both sides. And remember, when you got plus or minus, right, you want to write that number in front of it so that then you can easily see your two solutions. All right, with the plus, you'd have negative 3 plus 1, or y is negative 2. With the minus, you'd have negative 3 minus 1, or y is equal to negative 4. And at that point, you have solved your quadratic equation. You could plug it back in and check. Negative 2 and negative 4, those are the two values that you could plug into your original equation for y, and it would yield a true statement. All right, so these do have several steps. That's going to take some getting used to, all right? That's going to take some significant practice. It will get easier the more that you do, but you want to be aware of that. All right, so let's do one more here following the same steps. So remember, the first thing I said is you want to isolate the variables, and that's not happening right here. You've got an x squared on one side, you've got an x on the other side. So if I want to get all my variables on one side, the first thing I'm going to do is add that 6x. That's going to rewrite this as x squared plus 6x is equal to 1. This is the format I got to have. I need my variables on one side and my constant term, the thing without the variable, on the other side. Then I'm ready to complete the square. So this is where I'm going to take each side and add something to it. All right, so I'm putting little blanks in there. Now what I need to add is going to be 1/2 of the b term squared. So in this case, my b term is positive 6. So once again, I'm going to be taking 3 squared, which means I'll need to add 9 to both sides. Now notice when I factor the left-hand side, we did this one just a minute ago, I'm going to have x plus 3 times x plus 3. And on the right-hand side, I'm going to have 1 plus 9, which is equal to 10. All right, so by completing the square, I end up with a new equation where everything on one side is being squared and it's equal to a constant term. This is where I can apply the square root property, only when I get to this point. So I'm going to do that now. I'm going to take the square root of x plus 3 squared, and this will equal the plus or minus square root of 10. That's going to get rid of the square root here. We'll have just x plus 3, and the square root of 10 cannot be simplified, so we'll leave it just like it is. And then lastly, we want to get x by itself. All right, we'll subtract 3 from both sides. So I'm going to put that negative 3 out in front, and I'll be left with negative 3 plus or minus the square root of 10. Now again, remember, this is two solutions. Right? You could put it in your calculator and approximate it, but you'd have to round. So we're going to leave them exact, but we're going to write one with the plus, negative 3 plus the square root of 10. We're going to write the other with the minus, which is negative 3 minus the square root of 10. And at that point, I can't simplify anymore. So these would be the two solutions to this quadratic equation. All right, now again, I'll go back and work this one for you when I post the notes, but you try it. Try to work it on your own, right? Think about what you would need to do, and if you get stuck, you do have some basic steps that are defined here if you go in the Learn portion of Hawks. So notice this is exactly what we've been doing, all right? You will notice the first step here says, always make sure that the coefficient of x squared is 1. All right, if it's not, we'll talk about what you need to do, but you want to make sure of that. Then you want to isolate the variables and the constant term, get them on separate sides. Then you want to figure out what you need to add to both sides, write it as a square, and then take the square root of both sides. All right, that's going to be your method every time you need to complete the square. All right, so we talked about the fact that sometimes when you go to take half of the b term, it doesn't give you a nice whole number. It leaves you with a fraction. So let's look at one where that happens, which is going to be anytime you have an odd middle term. Now remember, first thing I need to do is get the variables isolated on one side. So I want this to be on the other side. I'm going to add 5 to both sides, so that I end up with an equation where the variables are on one side and the constant term is on the other side. All right, now at that point, I'm ready to complete the square. So I'm going to add something to both sides that will complete the square. All right, now we know what we need to add is 1/2 of the b term. Now the b term in this case is negative 7, and that needs to be squared. All right, so if I take 1/2 of negative 7, I'm looking at negative 7/2. And when I square that, that's going to give me a positive 49 over 4. Square the top, square the bottom. And that's what I'm going to need to add to both sides. Now, the left-hand side is not going to be too bad to factor, because remember what I told you. If you have something where it's not as easy for you to see the factors, just remember it's going to use whatever was 1/2 of the b term. So what I did here is I took 1/2 of negative 7. I got negative 7/2. So that's how this thing is going to factor. It's going to factor into x minus 7/2 times x minus 7/2. Now, on the other side, remember, to add fractions together, you have to have a common denominator. So I'm going to have to take 5 and write it in terms of a denominator of 4 so that this will match up, right? 5 is the same thing as 20 over 4. So on this side, I'm looking at 20 over 4, oops, plus 49 over 4. All right, now on the left-hand side, I do have my perfect square. This is x minus 7/2 squared. And then when I add my numerators over here, I'm going to have 69 over the common denominator of 4. All right, now this is where I'm at a point where I can apply the square root property. All right, I take the square root of x minus 7/2 squared, and this will equal the plus or minus square root of 69 over 4. Now on the left-hand side, right, those are going to kind of cancel each other out. I'm going to be left with just x minus 7/2. And over here, if I take the square root of the top and the bottom, I can't simplify the square root of 69, but I can go ahead and say, well, the square root of 4 is equal to 2. And then finally, we want to get x by itself. We would need to add 7/2 to both sides. I'm going to put that out in front of the plus or minus. And because I have a common denominator, I can go ahead and combine the numerators, write this as 7, and I forgot my square root. 7 plus or minus the square root of 69 all over 2. Now again, this still applies to two separate solutions. So if I need to write this as two separate solutions, right, with the plus, I would have 7 plus the square root of 69 over 2. And then with the minus, I would have 7 minus the square root of 69 over 2. And these would be, as far as I could go, I can't simplify anymore, these would be the two solutions to that quadratic equation. All right, you simplify as much as you can, but you're not going to be able to simplify everything to something pretty. And so when you get to a point where you can't do anymore, right, understand that you want to leave your answer in its exact form. All right, so again, anytime you have an odd middle term, it's not going to be quite as nice. You're going to run into some fractions when you go to complete the square. But that is where I would just make sure you remember whatever you get when you take 1/2 of the b term before you square it, that's always what you're going to see in your two factors. All right, so same thing here. Try this one yourself. Right, and I'll post the solution to that one when I post my notes. I want to do one more with you here, and that is just to look at what happens if you have something other than 1 in front of the x squared. And the main thing for you to remember is you cannot complete the square if the coefficient of x squared is anything other than 1. So if you start out with an equation and you see right off the bat there's something other than 1 in front of that x squared, the first thing you need to do is divide everything by that coefficient, because you can't have that. You need the x squared to have a coefficient of 1. And then you simplify. So this becomes x squared plus 6x is equal to 2. Now you're ready to complete the square. The coefficient of x squared is 1. You have your x terms isolated on one side. So now I'm going to add to both sides something that will complete the square. Now this is an even middle term. All right, so be pretty straightforward. Take half of the b term, which is now 6, squared, which means I'm going to be adding 9 to both sides. Now, when I go to factor that, right, I'm going to have x plus 3 times x plus 3. That's x plus 3 squared. And on the right-hand side, of course, 2 plus 9 is 11. And that's where I'm trying to get. I'm always trying to get to a point where I have something squared equal to a constant, because at that point, I can take the square root of both sides, as long as I remember the plus or minus for the constant term. So this will become x plus 3 is equal to the plus or minus square root of 11. And then to get x by itself, I will subtract 3 from both sides. I'm going to put that negative 3 in front of the plus or minus. And I can't simplify the square root of 11, so it has to stay. So my two solutions here, the plus would be negative 3 plus the square root of 11. The minus would be negative 3 minus the square root of 11. And at that point, I couldn't simplify any further, and so I would leave my solutions just like that. All right, and again, I'm going to work these last two examples for you. But the main thing for you to remember is as soon as you see that what you have in front of x squared is not 1, take that coefficient and just make sure you divide everything through by that before you start. All right, so I'll post those last two examples as well as any that I skipped over here. And then this is what you're going to need to work through the homework in section 10.1b. Now remember, I'm going to push the due date out to Wednesday for you, but I want you to make sure that you at least get 10.1a certified. Hopefully, you put the time in, you can get 10.1b certified before class on Tuesday as well. But if not, make sure you spend a lot of time in this section so that you can get any questions answered when we meet for class on Tuesday before this homework is due on Wednesday. All right, so we will go over questions on Tuesday, but we'll also be covering section 10.2 then. So make sure you use the video, you use the examples, and you really work hard on 10.1a and b before you come to class on Tuesday.